one on the left is a prototype from Philips where they have a screen that keeps functioning even if you roll it on. Okay, and the one. And the one on right is Samsung ka prototype device, what they call as.
Excuse me, ma'am.
Yes, please. हाँ बोलो.
Ma'am, polyethylene is already double bonded and it is unsaturated, so.
So you need a polyethylene. Okay. So you need a little more modifications, right? So why I said you need double bonds in here. Let me go back. So what I meant by chemical modification was कि जब आप अपने system में you introduce these delocalized electrons and you modify it, you need to connect it to a circuit to be able to extract those properties. I'll show you an example of a plastic that can sort of conduct. So
It's not double bonded. Only the monomolecule is double bond. But when you make a polymer out of it, it's single bond.
it's going to work.
Ethyl, the monomolecule is double bond.
So we have Shilpi, who is a chemist. Sorry, I didn't know about the chemical structure details. Shilpi.
So like the basic unit, monomer unit, which is ethylene, that has a double bond. But when you make a polymer out of it, it is a polyethylene, which doesn't have any double bond. But when you can, you can have some sort of branching and all, which might have double bond. But we are not talking about that because that won't be in the main chain. So in the main chain, if you introduce some double bonds, that will be, leading to some sort of electrical conductance. I think it's clear. Is it?
Thank you very much, Shilpi, for saving me at the right occasion. I'm sorry,
Thank you.
Yeah, thanks a lot. Very good question. A big round of applause for this young lady down here. I have not been asked this question so far, and I'm sorry that I didn't know the answer because I sort of work on the physical side of it. I never go, as a physicist, I never go and look into the chemical structures. So, thank you very much, Shilpi, again for the answer. So you need to have the delocalized electrons in the main chain. His question was polyethylene already has a double bond, so why does it not conduct? And what Shilpi answered was the monomer has the double bond. But when the monomers are linked together, they don't have a double bond in between. So in order to make plastics conducting, you need to have the delocalization of electron possible throughout the main chain and not only the monomer. Okay? So yeah, so now, I'm not able to move it. Can you? Yeah, आगे नहीं जा रहा, can you? Yeah, so, yeah. Actually, laptop is bigger. So these are the flexible displays I was talking about. So the question is, can you please change the slide for me? Yeah. So why would you want to use plastics that conduct electricity? I want an answer. Come on. Yes? Cheap. किसने बोला? Okay. So because the answers have already come up, so we need so we need plastics that can conduct for 3 reasons and many more. Because one being they are cheap, second being you can make flexible electronics. आपके जो आजकल कंप्यूटर स्क्रीन्स वगैरह हैं आपने देखा होगा about 10 years back you had huge CRT monitors. Okay, with the advent of technology all these things have come up and they have shrunk in space, and now people are trying to explore more possibilities. And as I showed in my previous slide, Samsung is trying to come up with a prototype device where they have a flexible display which can open up to become a tablet and close to become a mobile phone. And it is not one of those that Lenovo does. That's a hinge not in the main electronic circuit. This is like a flexible screen itself. So I'm like really proud to say when I quote this thing. So the Samsung now uses what you call as organic light emitting diodes, and they were actually invented in the laboratory I am currently pursuing my PhD in. So, and they were the one actually devised this technology of organic light emitting diodes, and there are a lot of people working on these flexible electronic displays, and they have very close tie-ups with Samsung and Philips. So that's why I could bring along these for you guys. And so when you're working on such devices, you need to work in something what you call as ultra clean environment. So what do I mean by, yes please?
Ma'am, the things which we do,
Yeah.
sorry,
Yeah.
the things which we do with the plastic, we can also do it by using leather also.
By using leather also. I'm not sure, but for using leather you'll have to kill a lot of animals. What do you want to do? That's not a sustainable way. So what's the question? Artificial leather is also available, yes. So what is your question? I can't hear you. Can you please switch on the mic?
The things which we do by using the plastic,
Uh-huh.
that can also be done by using leather.
So you are talking about artificial leather. So if you remember, my first thing was it has to be cheap, right? So they have to be cheap. You need to be cost effective. And plastics are by far, if you look at it, जब से उसका discovery हुआ है, ever since it's perhaps one of the cheapest material that is available around. And this is precisely why you want to use plastics. By plastics, I don't literally mean the plastic, the sheets that you use. I mean similar processing, similar hydrocarbons, similar cost effectiveness should remain. You are talking about artificial leather. I'm not sure whether it would be a good material for using making circuits, but I'm quite sure that it would be a lot more expensive than plastic. Okay, so when I talk about plastic, so how many of you have seen solar cells? कितने लोगों ने solar panels देखे हैं? वजन कितना होता होगा एक solar panel का almost, like the whole unit itself, by itself? कितना होता होगा? How much? कितना? 5 to 10 kg. वो पूरे वाले का? तो in a 200 volt. Okay, it's 5 to 10 kgs. They can be a little more than that. Sometimes they are about 100 kgs also, like depending on how much you want to extract. Anuj will tell more about this. He's going to take you through the industrial perspective. But if I tell you guys that this is also a solar cell, and this does the job equally well. I mean, not equally well, literally, but yes, so this is the next advancement in the solar cell technology. So these are nothing but plastic solar cells that can be rolled, crumpled, whatever you do, and that can be carried along anywhere. So kahin par baad aata hai, the whole area is flooded and you have no grid or anything that could provide service. So you could take a whole roll of this, roll it on, connect to the circuits, and your emergency, at least the medicine, you need fridges and other things to store vaccines and stuff. So emergency supplies can be rolled on quickly, right? So a lot of research is going on into what you call as plastic electronics. They are not as efficient as the silicon solar cell so far, because silicon solar cell जो आप घर में use करते हैं, it is about 15% efficient, and these are about, at the industrial scale, these are about 2 to 4%. But still, they are a lot cheaper, a lot cheaper when you look at the overall cost of the grid installation and stuff. And they are a little more rugged, and you can carry, they are light, you can carry them literally anywhere. And I'll be showing one of them in action. Anush, मेरे bag में भी होगा solar वाला. So I think this should work here in the. No, I think if they switch on, ये light switch on कर सकते हैं क्या? On ये front वाला. So the reason I asked them to switch on this light is so that I can show you a flexible solar cell in action. Shani, hold this, facing the light. So I have a small LED, it may work, in my hand, and it lights up. So I literally generated electricity like this. एक ही on the So, yeah, can you see this? कुछ black है तो उस पर आ जाएगा. हाँ दिखा. So, is it visible? और इसको if you turn it around, it will stop to blink, right? So it switches off. So it's basically I'm generating electricity right standing right here. It's a solar cell. So these are such lightweight solar cells, and in future what we expect is once the technology sort of advances to the next level, we expect that we will be able to coat buildings with such plastics, like जैसे आप टाइल्स वो पुराने ज़माने में एक wallpaper stacks लगाते थे ना, so you can put similar ones on the buildings, and each building can be a powerhouse of itself. So this is the next level of miniaturization we were talking about, and imagine the smallest feature of a device that is going on here, or for that matter in your cell phones. I was talking about how TV screens have shrunk in size. So हर passing time के साथ क्या हो रहा है? The amount of devices that you can fit in a given inch of your wafer or on your electronic circuit has increased. So जब हम इतने छोटे स्केल पर काम कर रहे हैं, तो we need to work in what we call as ultra clean environments. Okay, by ultra clean environments I mean, if you imagine this room has about 50 million to 10 to 50 million dust particles in 1 cubic centimeter of this room. Okay, in one cubic centimeter. And when I'm working in a lab, the lab I work in is what we call as a grade 100 clean room. That's the middle range. We have grade 1000 clean room, and grade 10 clean room is the cleanest you can get, where all these Intel, Pentium chips are fabricated. And by this 10 and 100 and 1000 I mean is these rooms are so well evacuated and dried that they have only 10 dust particles per cubic centimeter or 100 dust particles per cubic centimeter. And can you please come over on the stage? And this is the kind of attire that we need to wear to go and work in the labs. Please come up. So this is what we call as a clean room suit. And if you see, we have to cover our shoes, we have to cover the whole body, we have to cover head, and we have to cover our eyes. Sometimes we have to wear a helmet to cover the face as well. And then we have gloves on hand, which they don't have right now. And these suits are special suits. If you look, they are blue with the black linings, and these black linings are also quite special. I was educated about the black linings by Anuj, actually. So these black lines are special for the reason that जब आप इतने छोटे स्केल के डिवाइस पर काम कर रहे हैं, आपका डिवाइस एक डस्ट पार्टिकल का साइज होगा few hundreds of, like say 2 to 50 microns, okay? And जो आपकी उस पर डिवाइस है, that is of the order of 10 nanometer, about 1000 times smaller than a dust particle. And that's why you need to maintain such big clean rooms जहाँ पर कि आप ये काम कर पाएं. नहीं तो अगर एक डस्ट पार्टिकल आपकी उसके ऊपर चिप के ऊपर जाके बैठ गया, तो it will ruin a lot of devices, and that will be a malfunctioning device. Okay, so that's why you need such ultra clean environment, and not only the dust but the static charges, right? जैसे static electricity तो सब लोगों ने देखा होगा, static electricity can also shorten these devices. So these black linings in these suits are the lines for discharging, right? जब भी आप काम कर रहे हैं तो आपकी बॉडी को एक constant ground दे रहा है वो. You won't collect static electricity on your hands. So that's the lab environment we work in. So whenever we go and fabricate devices, these flexible organic electronic devices, we have to wear such clothes and work for hours and hours. And yeah, so scientific research is not a very easy discipline. It takes a lot of courage and a lot of hard work to be in there. But if you want to be a scientist, because that's precisely why I'm here, because most of the other careers are quite visible. So scientists aren't as visible as they ideally should be. हमें एक दो फेसेस ही दिखते हैं रोज़मर्रा की ज़िंदगी में. हम या तो कल्पना चावला को जानते हैं या अब्दुल कलाम को जानते हैं. या how many of you have heard Professor C.N.R. Rao's name? कितने लोगों ने सुना है? How and why do you know him? Yeah, you down there.
He's a physical chemist and he just got Bharat Ratna.
Yeah, he got Bharata. He got the highest civilian award of India. And yeah, he's one of the eminent scientists around. And so these are the only faces we know. And I think that's precisely why I'm here. So to talk to you guys about science and scientific research. Thank you very much to both of you. You guys been wonderful. And pointer yeah. Thank you. So a big round of applause for these two volunteers. And hey, you guys need to tell how are you feeling in these suits? Uncomfortable, comfortable, good, happy, elated?
Definitely uncomfortable.
Definitely uncomfortable. Okay. So what makes you feel uncomfortable?
Actually, I feel trapped in this thing.
Okay, precisely, yeah. So that's the kind of, how should I say, this is sort of a routine for us. It doesn't bother us anymore. First 2 weeks it bothers and then you're like, okay, I'm just used to it. So thank you very much. And I hope you guys enjoyed my presentation. And this is our lab in Cambridge, where we sort of make all these devices. This is a lab, this is not our lab. This is, I think, one of Samsung's or Cambridge Display Technology, which was a spin-off from the group I work in, and it was later acquired by Samsung. वहाँ का lab है ये. And yeah, so my thanks to. Yes, sir.
Take back one step.
Yeah.
Can you explain that center thing, how to only the hand?
Okay, so yeah, the central picture is special in the sense that, so these big rooms, जहाँ पर हम सिर्फ 100 dust particles या 10 dust particles per cubic centimeter हैं, they're very, very difficult to maintain, very expensive. So to bypass that, what we sort of have is what we call as glove box. They again have the controlled environment. Just आप अपने हाथ डाल के उसके अंदर काम करते हैं. But they are a miniature clean room in a way. But sometimes you need the full freedom to do all other stuff as well. Not everything can be done inside these. There are a lot of stages in the device preparation. So not everything can be done inside the glove box, but a lot of things can be done. So these are like sort of mini clean rooms. And thank you all for being such a wonderful audience. Thanks to my department and my supervisors, my mentors for sponsoring, and our sponsors for making all this possible. Thanks to my parents, because of whom I could do whatever I've been trying to do so far. And yeah, hope you guys have a nice day.